Mr. Mice is here, and this is part 2 of inverse of functions. So in this one, I'm going to go over how do we find the inverse of a function using algebra. So I have some steps here for you to follow, and if you want, you can write these down and keep them close to you, and remember what the steps are. It's really only 3 steps, guys. Switch the x and the y variables. Remember, we're dealing with an inverse, so remember in an inverse, the x and the y, the domain and the range, switch. So we're going to switch the x and the y variables, and then we're going to solve for y. Now, I want to be honest, some professors and some books, they don't like you to switch the x and the y first. They like you to solve for x, or I'm sorry, solve for y, and then switch them. But you know, either way, you're going to end up with the same answer. So we're going to use this method. Okay? So switch the x and the y variables, and then we're going to solve for y, and then if the function is an inverse function, okay, if your inverse is a function, then you want to use the notation f inverse with the little -1 hanging up there on the top, right? Okay, so let's go ahead and do that. Example number 1. We're going to switch. Now, this is not y. This is y, right? Yes, it is. Make sure you change this to y equals 2x plus 1. So that way you know you're using x and y instead of f of x. And we all know that f of x is equal to y because we've been told that so many times, right? So now we're going to do our switch. Let me make this black here. Y equals 2x plus 1. Now we'll make our switch. So we'll switch the x and the y. And we have x equals 2y plus 1. And solve for y. Subtract 1 over. Easy peasy. Lemon squeezy. So we're going to have x minus 1 over 2 equals y. Now, x minus 1 over 2, that is a line. A line we know is a function. So we know that our inverse is a function. So I'm going to say f inverse of x is equal to x minus 1 over 2. That, my friends, is how you find the inverse algebraically. Now, I'm not done yet. I've got a couple more examples, a little bit more advanced there. And then I'll give you a couple practice problems to try out, and then I'll go over those, all right? So let's take a look here, and we've got example number 2. G of x equals square root of x plus 1 minus 3. All right, so I'm gonna change this to y instead of g. What's up, G, y? Because we like you. All right, now we're going to switch the x and the y here. X equals square root of y plus 1 minus 3. All right, now in order to solve this, we're solving for y, so we're going to have to add 3 over first, right? So we're going to have x plus 3 equals square root of y plus 1. Because don't forget, we got to get the square root by itself. We've got to isolate that. So then we're going to square both sides. And we're going to square both sides. Square, square. And we're going to get x plus 3 squared equals y plus 1. Now, if you want to, you can FOIL this out. But do not say that's x squared plus 9, because it is not x squared plus 9. It's x plus 3 times x plus 3, which is x squared plus 6x plus 9. Okay? But I am just going to subtract 1 over. I'm going to get that. Now, this is a parabola, right? This is a parabola. It's a vertex. Hopefully you talked about that in Algebra 2 or in a previous class. This is a parabola, which means that this is, in fact, a function. So, we're dealing with g. Sorry. G inverse of x is equal to x plus 3 squared minus 1. And there is our inverse. All right? Okay, so let's do one more here, and then I will come back with a couple of practice problems. Let's do h of x is equal to 2 over x plus 1. All right, and so we'll go and find the inverse of that function. So in order to find the inverse, once again, we take y, make that equal to 2 over x plus 1, and then we switch the variables. All right, so we're going to switch it to x equals 2 over y plus 1. Okay, so we're doing the steps here. solve for y now. So this is kind of a little tricky to solve for y. I'm going to multiply both sides by the denominator, okay? So I'm going to get xy plus x, okay, because I multiplied this way, equals 2. So again, pretty much I kind of did this and cross multiplied, got that, cross multiplied, and got that. Okay? Now I'm going to isolate the y by subtracting x over. So I have 2 minus x, and then I'm going to divide by x. And I'm going to get y equals 2 minus x over x. That in fact is a function. So I'm going to write it as h inverse of x equals 2 minus x over x. Now how do I know? You're probably asking, Mr. Mises, I just had 3 that were functions. How do we know when we get something that's not a function to not put it in function notation? Well, if you get a plus or minus, so let's say you have a square or even power to begin with, and when you take the square root of both sides, remember when you take the square root of both sides, you need a plus or minus the square root of both sides. If you have to do that, then you're going to do plus or minus. Well, plus or minus is going to be above and below the x-axis, which is going to give you not a function. So that's pretty much the only time when you're going to get not a function. If I spoke very fast, just rewind, because you're watching a video. So just rewind. All right, so I will be back with some practice problems for you, okay? All right, practice problem time. Hopefully you wrote these down. I'm about to go over them, okay? So here's the first one, and hopefully you tried them out. So we're going to have x equals 1/2 y minus 2. I already skipped a step of changing this to y. Okay, switch the x and the y. I'm going to add 2 over and divide by half. Now dividing by half is the same as multiplying by 2, right? So I'm going to have 2x plus 4 equals y. So my inverse is a function, 2x plus 4. All right, now let's take a look at the next one, shall we? We shall. Okay, so we're going to have x equals y cubed plus 1. X minus 1 equals y cubed. How do we solve for that y cubed? We take the cube root of both sides, okay? So the cube root of both sides. We do not have to do the plus or minus cube root because it's not an even power. All right, so we get g inverse of x is equal to the cube root of x minus 1. All right, there we go. Let's do the last one here. H of x equals 3 over x plus 5. I'm going to go ahead and say x is equal to 3 over y plus 5. And then I'm going to multiply both sides by y plus 5 and get xy plus 5y equals 3. 5x, sorry about that, 5x. Subtract the 5x over. So I get 3 minus 5x and then divide by x. And I get my function h inverse to be 3 minus 5x over x. And there we go, guys. So, finding the inverse of a function algebraically.